Hi everyone and welcome back to Physics with Mr. Simons. Right, we make physics simple and we try to get you exam ready. Right, so today's lesson we're looking at the past exam question which was in the supplementary exam of 2018. It's on chemical equilibrium. This variation we're going to give you a graph that is testing our moles versus time, and we're going to use that to solve a Casey problem. So that is how this variation is tested, right? We know your late graphs, but at the end of the day, it all comes down to a lack of practice. The more you practice graphs, the easier it becomes. The quicker you see things, the easier you can solve, right? Let's look at the problem. So, question 6. Say the equation below represents a hypothetical reaction that reaches equilibrium, the closed container, after 2 minutes at room temperature. Letters X, Y, and Z represents the number of moles in the balanced equation. So we have XA plus YB gives me ZC. Graph below shows the change in the number of moles of reactants and products versus time during the reaction. Now they give the graph of number of moles. There we have graph of number of moles and products versus time. Alright, so my time goes from 0 to 8. Right, and remember they said after 2 minutes we reached equilibrium. Define a dynamic equilibrium and then use the information in the graph and write down the values of X, Y, and Z. So we want that X, that Y, and that Z. Right, again I'm breaking the question into parts to make sure that we answer each section without cramping our space. You are able to see everything clearly. Right, so without further ado, let's go solve the problem. Define a dynamic equilibrium. It is the stage in a chemical reaction. The rate of the forward reaction equals the rate of the reverse reaction, 2 marks. Now they say the equation below reaches equilibrium in a closed container after 2 minutes. So they say use information in the graph and write down the value of X, Y, and Z. So there are 2 minutes. You can see here for C it's 12 moles, A is at 8 moles, and B is at 4 moles. Right, so if we had to fill that in, that would read for 8, 4, and 12. But 4 can divide in all of them, so X would be A. There at this point it reached equilibrium, 8 divided by 4, which gives me 2. B, 4 divided by 4, which gives me 1. And for C, 12 divided by 4 gives me 3. So the value of X there would be 2, Y is 1, and C is 3. So hope you follow and you see how we got that 3 marks. Alright, now let's look at the next set of questions. So 6.3, they say calculate the equilibrium constant Kc for this hypothetical reaction at room temperature if the volume of the closed container is 3 decimeter cubed. Right? Then at time 4 minutes, the temperature of the system was increased to 60 degrees. It's the reverse exothermic or endothermic. Explain how you arrive the answer. So we're going to look here at 4 minutes and see what is transpiring there. Right, so without further ado, let's go look at the problem or the solutions. So calculate the equilibrium constant Kc for this hypothetical reaction at room temperature of the volume of the closed container is 3 decimeter cubed. Right, so we assume you remember that concentration at equilibrium, C equal to N over V, my moles divided by the volume. Right, so at 2 minutes it reached equilibrium. C would be 12 divided by 3, A would be 8 divided by 3, and B would be 4 divided by 3, my moles divided by my volume. So 8 over 3, 2,67, 4 over 3, 1,33, and 12 over 3 gives me 4 moles per decimeter cube. So you can see I just took the values. A was at 8, C is at 12, and B is at 4. So I just took those values and I divided by 3 according to that equation to get the concentration. So 1 mark for each one. I assume you remember Kc equals the concentration of my products divided by the concentration of my reactants, right? So we know according to what we found previously, that's 2A. So therefore that would become A squared. That was 1B, so it stays B. And C there was 3C, so therefore C to the power 3. So C is 4 moles, so 4 cubed. A squared gives me 2,67 squared. And B 1,33. And if I punch that all in a calculator, I get 6,75. Right, no units. So 1 mark for correct formula, 1 for correct substitution, and another mark for the answer for Casey. So I have 1, 2, 3, 4, 5, 6 marks. Now 7th mark for dividing by 3. Now 6.4, they say at time 4 minutes, the temperature of the system was increased to 260 degrees. Is the reverse reaction exothermic or endothermic? Explain how you arrived at the answer. So answer here is exothermic. Not exothermic, endothermic. So look at 4 minutes there. A and B, I assume you can see is my reactants. Ne? A increased after 4 minutes, so my reactants of A increased, my reactants of B increased. Right, C is my products, so after 4 minutes, C decreased. Right, so a decrease in products, increase in reactants, means that my reverse reaction is favored. Right, so reverse reaction, the formation of more reactants, ne? A and B, and products decreasing. So endothermic, because the increase in temperature favors the reverse reaction, the formation of reactants. And the increase in temperature favors always, according to Le Chatelier, a endothermic reaction. Alright, so hope you follow. Wish you nothing but the best. Continue practicing. God bless. Bye.